we've got our first speaker this morning is Professor Brian Josephson, who is a Nobel laureate, Professor of Physics in Cambridge University. So I'll just call Brian to the rostrum.
Okay, well, the title of my talk is not just homeopathy and memory of water, but also ordering. Now, it's not just order. Physicists are interested in order, like crystals and so on, but what we're concerned with here are also, I think, processes that generate order. But anyway, I'll be talking about that. I think, in fact, we're sort of starting a revolution in physics, which is perhaps similar to what one got with the quantum theory, which physicists at least will know revolutionized physics by being able to calculate all sorts of things precisely. Though calculating precisely may be the problem partly, as you'll see. But anyway, so I'd first of all like to say a bit about my own involvement with this. I'm actually probably one of the first people to have heard about Jacques Benvenist's important work. This was a conference on the island of Bermuda where the organizer, David Lorimer, said, I think you'll be interested in the next lecture coming up. And that was Jacques talking about his experiments on high dilution work. And so we interacted quite a bit, and I actually was able to persuade people at the Cavendish Laboratory, which is the physics department of Cambridge University, to have him give the departmental seminar. And I also had them video recorded on old technology videotape and for posterity. Hopefully, when he got his Nobel Prize, but of course he didn't live long enough. So hopefully we will now hear him speak.
So we've been working a lot since 10 years. Many people think that we are still counting cells on the side and doing our little things. I've been presenting this in congresses, especially in America, because I'm still a member of the American Association of Immunologists, but could never publish anything. And I guess that now things will be reversed for many reasons. Yeah, you saw this one, I guess. That's the only controversial slide I will show. Okay. Now, I wanted to make clear that everything we are going to present, it's not theoretical. It reflects observed phenomena, and there is no revolution at all. It's an evolution of the system, an evolution of the understanding what is going on between two molecules when they talk to each other, which is the basis of all biological phenomena. I don't know what you do, but when I read a mystery book, I always go to the last page so I know the issue, and then I come back to the book, because otherwise I get very nervous. So I'm going to show you the result of the talk. And some who are unhappy with the talk can leave after that. This slide is enough. The current theory of molecular signaling is the following. There is a ligand, molecule A, that connects through the receptor to the molecule B. And this will trigger a function. This is supposed to work through structural matching, like two teaspoons, one against each other. And this structural matching is supposed to create enough glue for the two molecules to stick together, and enough information for this information to the specific signal to pass on, and then to the next one, and then to the next one, all this in a very quick time. We are absolutely not, as has been printed and said, refusing the idea of molecule existing. of the ligand receptor interaction at all. Everything is the same. Okay, so what we are saying is that between this and this, there is a matching of two waveforms, which probably works through a co-resonating system. And we will...
All right, Charles, I think we ought to move on. He had this idea that it is the sort of signal that's involved, and this led him eventually to later kind of experiments. We actually tried this. He brought along equipment at the Cavendish, and the results were not quite significant. There was only time to do one test, and of the 4 samples, the one which had both been subject to, had the active material and be subject to succussion, the process involved in homeopathy, that was the only one which where there was reasonable coagulation. So, but of course that's only significant at the 25% level. But anyway, I actually looked up a couple of days ago. I realized I didn't quite know what he had done exactly. He had developed an in vitro test for sensitivity to allergens. You want to know if a person would be sensitive to an allergic material, so he developed a method whereby you could take cells from that person and see if they responded. And he found, there was a homeopathic doctor, a person in favour of it in his lab, said, why don't you see if it works with highly diluted samples? And he was very sceptical, but lo and behold, it did work. And then he did these tests on activation electromagnetically. He, I'll show that. That in a minute. What he did was to pick up a signal from the active material, and then you could transmit it over the internet or somewhere to another place, and that could be used to activate water. Anyway, so he submitted, not sure what happened to the colour, but anyway. So he submitted to Nature, and the referee said, well, we can't find anything wrong with this. It was a collaboration with lots of people, in fact. But after we publish it, we'll send someone to your lab to see if it's, to check whether it's valid. It's a very strange way of doing things. You normally check whether something is correct before you publish it. But he wanted to show Maddox up. There was a totally untutored people went along. We didn't understand things about biology, like some things sometimes work for a bit and then something goes wrong. So there was this rather nasty attack on him, and he was knighted for that, among other things. I think the Queen had, if she'd known about this, would have said, no, we can't have, he can't be Sir John. Anyway, okay, I want to get on to science, but before I do that, I'm going to talk about the non-science, the unscientific stuff. Here are 3 of the reasons people give for why homeopathy is totally impossible. I don't know whether I should embarrass the person who said that no molecules, no effect. If you look it up, you'll see a well-known critic who says that. Well, the idea is you've diluted all the molecules, so there can't be anything left to produce a cure. Of course, that neglects the fact that you might be doing something to water, and that what it might be doing to water is what I'll be talking about later on. So that's the first dodgy argument. Second one is actually a former head of department said this. We know things happen very quickly in water, and you want memory to persist for a long time. Well, that's a very spurious argument, because you could clearly have more than one time scale for different things, and it's just a non-argument. And the third dodgy argument is, well, if water could remember what it had been in contact with, it would remember everything that it had been in contact with in the past, and there'd be total confusion. But you might say the same about a magnet. A magnet would be affected by any magnetic material it came in contact with. But of course, what happens is that some things have a strong influence, and they produce the organizing effect. And this may be resistant to everything else. So that's what would happen with homeopathy. Your preparation process would have some effect organizing the water, and this might be persistent and not be affected by what other things the water came into contact with. The Benveniste actually found that people seem to have an effect. One of his people, if one of his people did the experiments, they got a very good effect, whereas another person seemed to wreck the effect. So clearly we're dealing with something rather complicated. Okay, now one kind of organization would be static organization, which is what physics is mainly concerned with. And this is actually a simulation by people at Princeton University. I'll show you extracts from their paper in a moment. But what they did was to make a model for, I guess the red must be oxygen and the white hydrogen here. They produced a model for how these things interact, including a tendency for tetrahedral bonds, because that's what the bonds are like. That's what the chemical bond of carbon is like. So they put in something which persuaded or tended to make a tetrahedral organization. And they found you got these large clusters like that. And there's some extracts from some of their, I guess you can look at the titles if you're interested, extracts from the abstracts. In the specific volume of small clusters and individual molecules that adopt highly tetrahedral arrangements, their four nearest neighbors is smaller than the bulk value. This means the formation of ice-like regions having a density lower than the bulk is cooperative. So the key word there is a cooperative phenomenon revealed by these computer simulations, and involves many molecules. So you can't think of molecules in isolation, which is the naive view. Another paper, we identify a structurally anomalous region bounded by loci of maximum orientational order at low densities, translational order at high densities. These are things that happen in crystals. You get a particular orientation of the unit cells and also as translational order. Anyway, this region encloses the entire range of temperatures for which the anomalous phenomena in water are observed. Because water is a strange substance, the way it starts expanding as you cool it down and expands further when you get ice. And we also find that these anomalies constitute a cascade. I haven't read the details of the paper, but that's rather interesting that you have steps. It isn't a single thing. They occur consecutively as the degree of order is increased. Okay, well that is the kind of static order that you can get in a substance. And now dynamic effects. Now, something I came across fairly recently, which is pretty well unknown, more music now. When you play music to water, it develops a structure, as you'll see here. Okay, now you may wonder how on earth you get these pictures. This is the invention of John Stuart Reid. A number of these videos on YouTube. It's actually by someone else because the videos he sent me have got lots of jazzy effects, and I thought it better to have one which isn't like that. But anyway, you have a camera on top which takes the picture, and he found the best, there's an illumination, a light source, and he said it's arranged in a conical arrangement, a light source, and the light then goes down to a cell with water in it, and above it you've got a signal processor producing the sound, and I assume that's loudspeakers above it. So you just play the music and see what pattern the reflected light or the transmitted light looks like. And have a short video showing the whole thing. That's
Hi, Sung. So this is
what
a
it actually looks
video
like.
showing the cancer cell 4
seen in the
being
camera.
imaged on the Cyma Scope. Here you see it on the back monitor screen of the Blackmagic camera. And if we come
go
down
and
to
look
the
at
Cyma Scope
the
itself,
thing itself.
you see there is
So
the
here
water
you see the
cell
water.
with the imagery actually happening in real time.
So, right, so there's this, I guess you can buy one of these Cyma Scopes or make it yourself, and it's a really remarkable phenomenon. I don't know how much it's just nonlinear physics, or he seems to think that things are happening at the molecular level as well. So there's lots of stuff on the internet. He also thought that it exhibited memory effect. Maybe the evidence is not that strong at the moment, but here he's talking to somebody about memory. Let me see, can I pause? It hasn't started yet. What he does is to apply a signal to water and see how long it takes for a pattern to develop. And it took longer the first time than subsequent times. And he says that's a general rule, which suggests that the water's remembering what's been done to it. So we just see this.
Experiment, take 1. Frequency generator set to 9.87 Hertz. Now this frequency has not been imaged before. The microliterage is 680. Going to ramp the amplitude up at the same moment as starting the timer now. Whoa, that took 6 seconds to reach full amplitude. Going to ramp it up again now. That took 5 seconds to reach full amplitude. Going to ramp it up again now. That also took 5 seconds to reach full amplitude. Going to ramp it up again now. 4 seconds to reach full amplitude.
That by itself is perhaps not very convincing, but he says there is more evidence. So now I want to get on to the physics behind all of this, the thing I'm interested in. As I said, I think we're maybe moving to a new epoch. Now, here's what my diagnosis, that's actually the chapter of the book, The Trouble with Physics, by Peter Voigt, I think. I think insisting that that your theory predicts numbers is restricting its range of applicability. In fact, it's not really applicable to biology because of a great variation between different versions of the same system. Looks like it works well with matter, but not with things like mind and meaning. Another thing is that complexity is probably important. Complexity and regular maths don't go well together. New physics is needed. So do we have anything? Well, this new physics requires a sort of new picture of what's going on. Various candidates, these are various a lot of people have talked about what's needed. Well, you could just say organized complexity, but that's obviously too vague to be scientific. But organization is the key. Implicate order is David Bohm's idea. He talked about order being enfolded and unfolded, and meaning coming out of it. Thing which is very important, I believe, is sign theory. This is goes back to the 19th century. Incidentally, cymatics goes back to, well, apparently Faraday first discovered these patterns in water. But anyway, Peirce introduced the idea of semiotics. And we say the difference between this book by Hofmeier on biosemiotics, which makes the point that physicists talk about information, whereas in biology you have signs being that they are information directed to an end, and that's not really studied in physics, but it's important in biology. So that's then been, in the latter half of the second century, a few biologists took up the application of sign theory to biology, which people had just assumed it's relevant to things like human communication, but these people said, well, no, perhaps it's relevant to biology generally, which I'll be showing you. And interesting ideas came out of this analysis. Semiotic scaffolding, semiome, which is a semiotic analogy to the genome, semiosphere, code duality, all these ideas come out. Though they're not really treated so much by physicists, and I think physicists need to get into this and apply their special methods. However, there's a physicist, Karen Barrard, who's written a book on agential realism, and he's taken the idea that various agencies work together to produce a phenomenon, which of course is a biological thing, and a special kind of interaction which he calls intra-actions, and makes links with quantum physics, particularly the observation process, which is actually complicated and involves, well, I say the collapsible wave function involves a number of things working together. So she's made connections. I actually didn't include, what's her name, Ruth Kastner has something called, well, it's an interpretation of quantum mechanics where systems communicate with each other. And I think I've been interested in the rather intuitive idea of Alexa Yardley, ideas like oppositional dynamics. Okay, now let me talk a bit about the question of order. And an idea there is that order and disorder go together, and ordering, as I said. Now, the first point is that order arises spontaneously. In fact, Peirce's semiotic idea said really nature is fundamentally random, but it does organize itself against the background of randomness. So order arises spontaneously, and the creation of order or ordering is a part of nature. But order includes disorder. These are fluctuations which are, when you talk of something in equilibrium, there's also disequilibrium, as fluctuations are part of equilibrium state. These go together like yin and yang. But in physics, you don't have much in the way of organized disorder, where parts relate to each other in special ways. But anyway, to have order requires ordering to be present, otherwise the fluctuations would grow and grow, and ordering processes stop the order getting too great in an equilibrium situation. Now, getting back to a point I think I made earlier, crystals have order, but that is static order. In life, there's a dynamic kind of order. So we have ordering within activity. But we don't understand this very well. So the development in physics, the next stage in physics, I'm predicting, will involve understanding it better. Right, now, Just going to mention a couple of ideas which there have been. There's this idea of semiotic scaffolding. Well, first of all, a definition. Scaffolding is whatever it is that supports a given kind of activity. So when you do something like learn to walk or talk, there's something in the background which supports that. Humans learn to talk because there's a special kind of structure which lets people learn to talk. So it's a two-way thing. As in the next row, we have scaffolding gives rise to activity, but activity also develops the scaffolding. A particular example of this is language, where you have, as you learn language, your language capacity gets better if the scaffolding of your language activity gets better. There's also two processes. There's becoming active and there's a less active stage. You have to be more active and more disordered when you search for new things, and then you have to settle down to stabilize that order. So that's another thing. Now, I mentioned the case of language, which I gave a talk a few years ago at a conference in Imperial College, where I hadn't come across many of his ideas, and I said, well, language is an amazing thing. It comes from almost nothing and develops into this amazingly intricate structure. The key thing is that there are many components working together as a unit. So that's a basic thing. Why do they work as a unit? Well, it's a simple answer. Working together equates to stability. So, in other words, you try to reach a stable situation. Once it's stable, they tend to lock into that position. So that's a very crude explanation of why we get these complicated structures underlying biological activity. But it isn't just things naturally coming together. This scaffolding pushes things in the right direction. We sort out what happens in language because we have the skill for doing it. Let me give an example of how we have a skill of putting things together. If you're assembling something mechanically, in the first place you don't do it very well, but you get more skilled in placing them correctly to put things together. So this is roughly what's going on when we learn. For example, with language, you have to put the bits of language together in the right way, and once you know the grammar, you can put the words together in such a way that it has meaning. So that's another aspect. And so nature sorts things out eventually. And gets better and better at it over time. Well, these are just very qualitative ideas, but one would expect that the science will figure out the proper basis for these things. So what kind of investigation would there be? Well, first of all, there's kind of looking at nature to see what regularities there are. That's the sort of thing I've been talking about. You develop theories, some being mathematical. I think some mathematical models will justify ideas about what happens with complex systems, and computer models. And I had a student, George Osborne, no relation to the ex-chancellor and editor of the London newspaper. This is just on the left you have the website where you can read this. This is how its program works. It sort of shows that you can treat this scientifically. Unfortunately, the powers that be a laboratory, amazing though it may sound, said this is not physics, you can't work on this project anymore. I was very annoyed because I had this whiz kid in developing computer programs, and it might have gone ahead a lot, but the powers that be, who of course could control what students could do, stopped it happening. Now I think, but after a couple of decades, it is moving forwards. I'd just like briefly to mention the circular theory, just one idea. It's a very obscure the book sounds almost like nonsense. In fact, she wrote to me, everything's a circle, and eventually I learned a circle is a very subtle idea. It actually makes more sense if you talk in terms of scaffolding, and she's really talking about a universal scaffolding concerned with universal principles of how to put things together and stop them together, which of course is important in language. You divide speech into units, you find the right kind of units, and then you put them together. So that's would be the fundamental scaffolding of reality, and it's there's also this idea. It's a hidden background. We don't see very directly what enables us to be good at language. Okay, so let me go back. Yeah. Okay, so what I'm going to say. Yes, one idea I didn't put on the slide is this idea of oppositional dynamics. Two things which are distinct and yet are well placed to go together. And this is a key thing which comes out of this these mechanisms. Okay, now the last but one slide. Where do mind and matter fit into this? Well, scaffolding, a point emphasized by people in biosemiotics is that these things work by picking out what is meaningful. So meaningful information can enforce structure. So you get mind and matter. The information is the mind aspect, and the things more structure-like that are built up of matter. So we'd expect mind and matter to be built up. And I'd hope, as John Archibald Wheeler did, that these principles will give rise eventually to all of science. You have to go up step by step, show step by step how we work from something very simple to the kind of universe and laws of physics that we have today. And of course, the biological signal would be a special case of that. Now I'm going to finish with my own cymatic picture. This was not. This was something, a video I took naturally, and it was not as music played by my daughter's band, incidentally, as a background, but the music is not what's producing these intriguing patterns.
You'll agree that was very revealing, very interesting, especially watching those shapes in the water. That's incredible.